All right, so we have 4 equations here, and it says determine the number of real solutions for each given equation. Now, all of these will have 2 real solutions if they have a real solution. In other words, we're trying to figure out if it crosses the x-axis or not. Because of the shape, because it's U-shaped, it's going to cross the x-axis twice because it's symmetrical about the axis of symmetry. So we're just going to graph each one of these, and then the ones that cross the x-axis are going to cross twice, and that'll be 2 real solutions. And then if it doesn't cross the x-axis, then it's no real solution, and it's a complex. We're not even going to deal with the complex number thing today. We're just determining if it's real or not. Okay, so let's just graph this. Turn on your calculators, go to y equals. I'll pull up my little screen here, and let's plug this in. So the first one is negative 3x squared plus x plus 12 equals, and I'm just going to graph that one. Okay, does that cross the x-axis? Sure does. So let's take a screenshot of that. How many times does it cross the x-axis, though? 2 times, right? So let's just take a picture of that. And we'll put that somewhere over here. I'll make it a little smaller so we can. So the first one has 2 real solutions, right? Well, I'm gonna graph them all first, and then we'll go through and look at it again. Now for the second one, so we're gonna go back, clear that out, and we're gonna say 2x squared. Now I want you guys plugging this in your calculators too with Mr. Adams, because I want you to be familiar with how to use your calculator. Make sure you get the same graph I get, okay? Because I might make a mistake. For example, did you notice that I put a negative sign instead of a minus sign? Well, that would have screwed it up. All right, there we go. Let's see what this bad boy does. That one doesn't cross. That one does not cross. So that's kind of an important thing. So let's take a screenshot of that. I don't want to do that. All right, let's graph the third one. Turn our graphing calculators on. And clear that one out. So I'm going to hit y equals, hit the clear button. We're going to do x squared plus 7x minus 11. Hit graph. Now that one crosses for sure twice. So let's let me take a screenshot of that. And then the last one is negative x squared. Now here's the trick here. Students ask me sometimes, do I put a negative sign or do I do minus? Because it's the first term, that's a negative x squared. I'm not subtracting it from anything, so I'm going to put the negative sign, then x, then squared. Now I'm going to say minus, because I'm subtracting 8x from x squared. It's subtle, but unfortunately the calculator doesn't know the difference. Minus 16. We'll graph that. Now that one might not even show up on the thing. No, it did. Oh, that's a good one. That's a perfect square. We'll talk about that one. All right. How many times did that cross? Only one time. Multiplicity 2. So we got to determine if it has one solution or two. So let's take a screenshot of that. All right, so let's go through here and jot some answers down. So our first graph is this one, and it clearly crosses here and here. So that means this one has two real solutions, correct? So we just say two real solutions. The second one does not cross the x-axis at all, so it has 0 real solutions. Or you could say no. I'm going to try and use the same terminology. No real solutions. Now, the third one is this graph right here. Whoops. The third one is this graph here. Clearly, it crosses twice. So that one has two real solutions. And then the last one, it just touches right here at -4. Now, I'm going to be, the publisher says that it has one real solution. But if you were to ask a pure mathematician, they would say it has two real solutions, multiplicity 2. But I'm going to tell you to put down one real solution. If we were to solve this thing, we would get x equals -4 and x equals -4. It's okay. But it has one real solution because both of the solutions are the same number. All right. That's it for that one.